I'm setting off for a drive, and to fill in the time, I thought, why not have a little bit of fun with physics? That's what boring people say. In cardigans. Yeah, they want to talk about physics and they want to be boring. So what they do, they put the brown cardigan on with the patches, and they say, "This is kids. This is going to be fun," and it never is. Neither will this be. Sit down. Just take your punishment. No. Look, I'm only talking to myself, but I've got a bit of a drive, so I've been listening to a podcast. No, I haven't. An audio book on physics. I'm trying to work out what the hell it's all about. Chai latte, I'm hippie. All right. Speaking of hippies, there's a couple of books I've never read. Now, I'm listening to an audio book on all sorts of physics, but the chapter I've been listening to is on quantum physics, and I loved how this guy put it. He said, there is a thing called quantum physics, believe it or not. And he said there is also a thing called philosophy, and so on and so forth. And he said there's a couple of books on the market. Now, I can't remember what he said. I've heard of them before. Tao, and they were two, something like something to do with dancing, something like quantum physics and Zen dancing. I can't remember what those books are called, but they're very famous. The art of bloody quantum bloody physics and Zen Tao up in the mountains, with Einstein type thing. Two famous books, I can't remember what they are. And he said it was a real fad for a while, because when people started to realize that physics at a very tiny level, at a nano level, acted weirdly, they tied that in to ancient philosophies and all that sort of thing, and they said, finally, it all comes together, because this matches with the whole Buddhist, thing, Hindus, bloody, Bhagavad Gita, bloody, all that stuff, the Vedas, all that, And he said, very interesting books, he said, these two books, where they were able to find this synthesized everything, Eastern and Western, philosophy and physics and everything, brought it all together in these two wonderful books. And he said they were great books. The only problem was all a load of crap. He said, no, he said, because they said there's some, the books were about, the idea of the books were that the mind, quantum physics proved that the existence is linked to our thought processes, your mind, and what you think is linked to physics, quantum physics, the way the world works. Now, what was the example of that? Let me see. It was all to do with Schrodinger's cat and all that sort of stuff, and how you can get a thing called a particle, by which we might mean an electron or a photon. Electron's a tiny little particle. It's a little bit of wave too, but and a photon of light. Like a little bullet of light. Like the sun. The sun fires a bullet through space. One little bullet, and that's like a little light particle, and it comes all the way through space and into the Earth's atmosphere. And if it lands all the way down here and into my eye, I think it's gone through space there too. I think it's gone right through space, because even as it travels through the atmosphere, it actually missed everything. Otherwise, how did it get to my eye? So it was traveling in space through our atmosphere too, because most of our atmosphere is space. Damn it, most of me is space. Because if you go inside an atom, most of that's space. Anyway, maybe that photon of light banged into an atom on the way, and then that atom emitted another piece of light, and that piece of light hit my eye. But by and large, I think most of the light that comes from the sun, in order to get to my eye, the retina at the back of my eye, in order to get to that, I'm pretty sure it has to actually, by and large, except for a few exceptions, some photons might actually just bounce out. It might be a little bit of a billiard ball thing where a photon of light hits an atom, and then that atom gets excited and emits a photon of light, or I'm not even sure that. Yeah, it could, or it might even emit a lower level of light, that I can't even see because it's got a shorter wavelength. But the point is, by and large, all the light. There it is, right there. I'm looking at the sun. Keep your eyes on the road. There's rays of sun right there, bang, going in my eyes. I should have my sunglasses on. I'm pretty sure that about 4,354,000 photons, little bullets of light, actually just hit the back of my eyeball. Went through there and hit the back of my retina, my retina, and got stopped dead, because they would have hit little, photo bloody sensitive thingies at the back of my retina, and turned into electrical impulses, and I went down my optic nerve and went into my brain and said, "There's the sun." And then another part of my brain said, "Hey," to that part of the brain, because we've got different portions. "Hey, keep your eyes on the road." That's what's going on in my head. There's a war going on in there, and it's all about that. Anyway, so stream of consciousness. This obviously, I don't even know what I'm talking about. But the particles of light, you see. So now. All these Zen Buddhists, who learned about quantum physics, and they said, this brings it all together, because, Schrodinger's cat, which was alive and dead at the same time. Don't worry about that. It wasn't really. Schrodinger was actually fighting against himself with that example, but that's a whole other story. Anyway, what happens there is you can get a particle. It took a long time to get to that, didn't it? Like an electron or a photon. See, I can bring it back. And let's just take an electron. I'm pretty sure that can be split. I don't think I can do it. But particles, I don't know, photons, protons, neutrons, electrons. Protons are a lot bigger than electrons, so are neutrons. Protons aren't exactly the same weight as neutrons. That's a whole other story. But anyway, one way or another, these particles, they're not the smallest thing. They've got things inside them. And they can be split. Now, don't ask me about the physics of that, but it can be done. You can split a particle into two particles, and you can give them names, like Mary and James. So you've got these two particles, Mary and James. I'm making that up. They're actually called up and down or something, or plus or minus or something. The names don't matter, because whatever names you give them, those names don't really relate to their nature, their spins, for example. But they've got properties, because everything in the world's got properties. I've got properties. I've got a wavelength. But I'm a particle. But the reason I don't act much like a wave, don't worry about this bit, is because I've got an extremely long wavelength. You call me fat. Okay, but I've got a massively big wavelength. Huge. I reckon my wavelength might be bigger than my wavelength would have to be huge. I wonder if my wavelength is longer than the distance between here and Jupiter. Anyway, I suspect it is. You know, that's why I don't suddenly disappear from here and end up where I'm going, because that's what a wave might do. You know, because there's a bit of uncertainty about waves. Leave that one alone, Charlie. Be a quick trip. You know, if I was quantum in nature on a macro scale, though, this would be a quick trip. I'm using a bit of petrol here. I'd save a lot of money, because I could be sitting here. I'm going to Dandenong, you know, and I could be sitting here and go, oh, there's just as much, yeah, a little bit. Look, the chances of me actually sitting here on Balti Bridge, almost alone because it's locked down, you know, I should be turning the camera around. The chances of me being here aren't exactly one. You know, I feel like and the only reason it feels like the chances that I'm sitting here right now is one. Well, that's only one chance, isn't it? The chance that I'm sitting here is 100%, is because I've got a very long wavelength. But you know, there is a slight chance that I could just disappear from this car right now and pop up where I'm going. You know, pop up on the couch next to my Uncle George, ready for the footy. There is a chance, but it kind of really doesn't happen very often. You know, things the size of me just disappearing from here and ending up over there, for a couple of reasons. One is for reasons of safety. Because if I suddenly disappeared from this car would careen out of control, and career as well, because that's a word. And are you feeling it? I just went past a sign. It's the Premiership Cup, and they've got the Melbourne streamers on the left of the cup. It's a big sign, you know, to advertise the grand final. The grand final's on today, and they've got the Bulldogs, the Footscray flags, the streamers on the other side. That's back there. But I'm off to see the grand final, and I'm going for Melbourne. They haven't had a premiership since I was one, since the Beatles were here. You didn't see that. It's an old shirt. Right, now, so, a particle. I'm a particle, but I'm a big particle. Like a big fat one. But little particles, it's unlikely that I'm going to disappear out of this car and that this car is going to just careen off the side of this ridge that I'm on. I'm going past South Wharf here, and in a burning ball of flame, go right over the edge there and land on someone who is double vaccinated. That would be ironic. Anyway, so there's not much chance of that because I'm too big. But when you go down to a very small particle, like an electron or photon, or some other particles, there's a lot of particles. I don't even know what all their names are. One of them is called strange. It really is. That's strange. But anyway, so grab a particle, split it in half. Now each of those two halves, you know, might be called Mary and James, I think I called them. Right, now, but one of those particles, but here's the thing, those two particles are transgender. And I don't, you know, I'm not being overly facetious here, it's true. That's how weird things get in quantum physics. Are you saying transgender is weird? You know? Well, I did then, but this isn't a politically correct podcast. It's a physics podcast, and the idea is to get my point across, even if it hurts. It doesn't matter. I'm transgender. Don't worry about it. So I'm sensitive. I got the biggie. So I'm having a lot of drinks. I've got to truck up my ass as well. All right, so Mary and James. Now, the funny thing about these two subparticles, and it is funny, the funny thing about these two subparticles is that one of them might be Mary, the one on the left. Sometimes that one's Mary and sometimes it's James. But the other one is always whatever that one ain't. So, let's say that one's Mary. Well, that one's James. There you go. They can't be Mary, you can't have two Marys. Can't have it. But the funny thing is, that one can flip to James. Transgender. But the funny thing is, if that one flips to James, that one flips to Mary. Instantaneously it would appear. So they're linked. The two half particles, even though they've been, the original particle has been split into two half particles, they're like twins, forever joined and yet forever separate, or forever different. They've got, one's Mary and one's James. One's up and one's down. One's left and one's right. One's spinning this way and one's spinning that way. They've got different properties, very similar, but different, opposite. They're opposites. Now here's the problem with this. Mary is Mary, maybe, but that could be James as well. Because that's what quantum physics is like. You look at her, hey Mary, how you going? And you might take her out, and bring her back to your apartment. It's always an apartment, isn't it? I've got a house. All right, but you bring her back to your apartment, hey, put a little bit of music on, blah, 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 blah. Everything's going right, and all that sort of stuff. And suddenly you find yourself singing Lola because she's just flipped to James. Fuck. You know what I mean? That's all right, because I'm, like in such a situation, you got to go with the flow. Otherwise, you're not a good person. I just went through the tunnel progressively, because if you take Mary home and the lights are low, and you're singing Met in the club down in Oslo, you're singing all these songs and you got Mary there, and suddenly she's James, and you think, oh, hang on, wasn't James back at the club? He was. And you brought Mary home, but now Mary's James. She's flipped. But back over in the club, James, who you met earlier, he flipped to Mary. He's Mary. That's how quantum physics works. Now the funny thing is, when Mary flipped just then and became James, over at the club, which is a good 5 kilometres away, he flipped at exactly the same time. Now, when Mary decided to flip and become James in your apartment, now, Mary's an electron, but electron rides. Somehow James knew about that over at the club, and he flipped into Mary. So two instantaneous transgender flips. You know what I mean? Now this is interesting because they're two electrons. You know what I mean, really, but they've been split, and that can be done in experiment. That has been done. People know how to split, like to split a particle into two subparticles, People know how to do this now. The first time that was ever done, I think, was 1989, which was nobody told me. I was I was finishing off my physics course at that time, and I never really understood physics back then. I'm just learning it now. I just learned to answer the questions back then. But if you ever get a degree and everything, after you finish the degree, then figure out what the hell it was all about, because that's the way it's done. You really do. The only time you really learn is when you self-learn, and I'm busy doing that right now. Anyway, here's the problem. Einstein had a problem with this too, a big problem. This has been done. What they did, they split a particle like Mary and James, or up and down, call them whatever you want, and they split them into two, and they both had opposite spins, as they should. But when this one suddenly flipped into the opposite, like it was spinning left, spinning left, spinning left, spinning right straight away. This one was spinning right, spinning right, spinning right, spinning left. Now they both did that at the same time, but they were separated by such a distance that, let me think, I think light can travel 10 feet, 10 feet, I'll use the old imperial, in a billionth of a second. Now, even if I get that wrong, it doesn't matter for the purposes of what I'm about to say. 10 feet, right? Or maybe 5 feet, you know what I mean? But anyway, what they did in 1989 is they got we're talking two subparticles here, with opposite spins. Now, what they did, they split two particles, Mary and James, and they split them, they separated those two particles a distance of 20 feet, maybe 15 feet, maybe 11 feet. But the point is, there was no way, and then tested separately when this one, maybe the details of what I'm telling you here are a little bit wrong, but the point is right. What they did, they said, let's check when this one switches spin, when this one turns from Mary to James, when this one turns from left to right, let's check when that happens. And they checked that and timed it, you know what I mean? You could do that with experiment these days, modern technology, 1989, not too long ago. And then they timed when this one over here flipped as well. So this one flipped from, left to right. Like, let's say it's spinning. It's not quite spinning, but it's got a property, just like a proton has a property of being positively charged. An electron has a property of being negatively charged. Who gave them those properties? God, if you like, who cares? Point is, they've got them, all right? I'm here in this car. Who put me here? God. Or maybe he didn't. Who cares? I'm here, But the point is, this thing over here had a property of a left spin, a left spin, had a property of being Mary, and was left spinning away quite happily. And there's a guy over there, it was in a Japanese, I think it's Hitachi, the Japanese lab, and he said, all right, let's watch this, and I'll put the timer on it. And then he put the timer on, this one flipped to a right spin. Now, at the same time, over there, 20 feet away, another Japanese guy. Japanese are really smart. He was waiting for the other one to go the opposite spin, So this one said, at 12 o'clock, dong, this one flipped to left spin. And this one, and the other guy said, and then they came together, these two Japanese guys, all right, when did yours flip? 10:01 exactly, And when did yours flip? And he said 10:01 exactly too, And I went, so somehow, that one decided to go, flip from Mary to James, and that one did that at the same time. How did that one know that one flipped? How did they know that? Like, when that one flipped, the distance between them, there wasn't enough time, even at the speed of light, for this one to let the other one know it was about to flip. So Mary over here switched to James, And James picked up the message over here that it's time to turn into Mary faster, sooner, quicker than even some sort of message to be passed from this one to that one at the speed of light. So something is travelling faster than the speed of light. Something. Sometimes I think nothing can travel faster than the speed of light. Sometimes Einstein. That's what Einstein said. And yet something has here, hasn't it? Phases can travel faster than the speed of light. But that's all of the story. A shadow can travel faster than the speed of light. But, at sunset, when suddenly the sun peaks behind the cloud, sometimes peaks behind a mountain. So, sun drop. The last bit of sun drops behind the mountain, and the shadow is way over at Mount Dandenong, and suddenly it's in Fiji. It's in Melbourne, and suddenly, just a nanosecond later, because of just the sun just went down at the right time, the shadow, it was daylight at the top of Mount Dandenong, and a second later, just a tenth of a second later, the shadow moved from Mount bloody Dandenong, all right, across to Geelong, just like that. No, the other way. Sun goes down in the west. Shadow. Yeah. You know what I mean? Some things can go faster than the speed of light, but can real things go faster than the speed of light? Well, not macro things, but maybe some of these weird things can. Right. Somehow Mary and James here, the two half electrons, two half particles, have transmitted a message to each other. They've communicated at a speed, apparently, that's faster than the speed of light. And that's weird, and I don't know what Einstein made of that. He did make something of it, but I haven't kind of gathered what that was yet. He was basically still pretty Jewish, I think. I can't speak for Einstein because he's smarter than me, but I think he sort of said, that's just God. It's just property somehow. Actually, I think he was quite perturbed about it. But the funny thing is, if you put those two half particles in, if you put them each in a box, those two particles, half particles, you put those two half particles in two different boxes, now, you can't see them, but each of them might be Mary or James. There's an uncertainty as to which is which, and doesn't that happen in real life a lot these days? But anyway, it's true, all right, so you've got an electron and you split it into two particles, and you put one of those half particles, two subparticles, and you put one of those subparticles in one box, and you put one of the other subparticle in another box, and then you shut the box. You shut that box and you shut that box, and you sort of say to yourself, I wonder which one's got Mary in it, because I'm looking for a date. And if I open the wrong box, I might get a nasty surprise. That was homophobic or something, maybe transphobic. But the point is, I'm only talking physics here. I'm not trying to be nice. I will do a progressive activist episode later, in which I'll be very nice, but not yet, because all I care about is getting the physics across to myself, because I'm just talking to myself. So what you got here, as far as I understand, as far as I've heard, is that I've never seen it, because some of these half particles, they're so small, they're smaller than a photon, and so I will never be able to see them, because you can't see anything it's got a smaller wavelength than a photon of light, because it can't touch the back of my retina. It can't activate my bloody sensitive little rods and cones at the back of my bloody eye. So I can't see them. I have to get machines to see them. Alright, but I can't even get machines to see these two half particles. I kind of have to trust that they're in there. There's ways of knowing that, because you can put them in there. Modern science, 1989, not so long ago. So, what you do is you're staring at these two boxes and you say, which one's got Mary in it, which one's got James in it, because I want to open the right box, because I've got a very important date back at my apartment. And you can say that there's a 50% chance that Mary is in that box and a 50% chance that James is in that box, which means, of course, the other way around, you know. But at any point in time, you don't know. You know, there's only a 50% chance that box is gone. Look, are you feeling lucky, punk? And this is interesting. This is kind of that uncertainty sort of stuff, you know, around quantum physics. There's you know what? There's only a probability. You know, you have to talk in probabilities here. You can't say James is in that box, Mary's in what box, or whatever. It's not even worth betting on it, because they can change, you see. So what you say, whilst that box is closed, the best you're ever going to do is, and while the other box is closed too, the best you can ever do is say there's a probability that thing, that little half particle in there, is, you know, has got a spin of left, or a spin of up, you know, or a spin of one, whatever you want to call it, or a spin of Mary. But the one thing you can know, if that one's got a spin of +1, you know that one's got a spin of -1, because they came from a particle that had a spin of 0 electron, you know, let's say. What happens to the charge of an electron? Forget that it's an electron. Does half the charge go to that one, half charge go to that one? I'm not talking about electricity. Alright, just take just a particle. Forget that it's an electron. A particle. I'm not even sure how electrons work. Alright. So, the way quantum physics works is that, you know, all the little particles inside my body, all the little bits and pieces, there's only a probability, you know, there's a probability that some are spinning left and some are spinning right and some are spinning up and some are spinning down. All I can talk about is probabilities. So quantum physics, the mathematics of quantum physics that you need is a higher mathematics than the mathematics of just ordinary everyday life. In ordinary everyday life, I am doing 81 kilometers per hour. So there's not much uncertainty in that. You know, if I keep at this speed, then in an hour I'll be 81 kilometers down the road. Right? There's no uncertainty about that. But in the quantum world, if I was small enough, you know, such that my wavelength is really big. I think it goes from here to Jupiter. Such that my wavelength, well, you know, if I was a particle, if I were a particle and you were another particle, would you switch genders with me anyway? And would you have my baby? What sort of baby would that be? Well, the only baby that two half particles can have is to, I suppose, get it on, being a gong, and become a one particle again, and lose all your spin. Anyway, there's only a probability. This is the problem with quantum mechanics. It's very real, but you don't know where stuff is or what stuff is until you open the boxes. Now, here's the thing. This is where all the Zen Buddhists came into the picture, because there were some early physicists, And I don't know which ones they were. I get confused by all their names. There's names like Schrodinger and Einstein and Bohr. He had a good name for a physicist. Bohr. I think it was B-O-H-R. It may well have been B-O-R-E. In the translation from the German. But the funny thing is, the Buddhists and all that started jumping over all of this, because when they heard that that this subparticle over here in this box might be James and might be Mary, but only becomes one or the other if you open the box and look at it, the Buddhists, said the mind is making that thing James. Like, that thing only becomes James for certain once the human brain observes it. Before the human brain observes it, it could be Mary. And the Zen Buddhists got all excited and said, physics, Western physics, has finally unified itself, because that's what we're looking for, unification of all the sciences, a unified theory of physics and Zen, unified itself with what we've been saying all along since the Vedas, since the Aryan race came through the bloody pass. What's that pass? The pass that comes from the steppes of Asia down into India. What is that pass called? I know it very well. Okay. I'm thinking Kathmandu, but it's not that. All right. Now, since then, we've been saying this stuff that the human mind can bring on a thunderstorm. A lot of people say that these days too, and they're all wrong. But that's all right, because this isn't conjecture anymore. This quantum physics stuff. It's been tested. I'm not going to get to all of that, and so it's not actually conjecture anymore. Some of this stuff is just physically accurate. You know what I mean? Because we've seen it, not with our eyes, but with our instruments. But doesn't matter. That's a whole other episode I'll never do. And anyway, but the Zen Buddhists and all that sort of stuff, the Tao up in the mountains in China and all that sort of stuff. Is that where they come? The Tao? I always think the Taos come from Saudi Arabia. See, now you're being racist. Right, I'm almost at my destination. Unluckily for me, I didn't disappear back there on Balti Bridge and reappear here in Dandenong instantaneously, save some petrol and lose a car over the bridge on top of that guy that didn't get vaccinated. Get vaccinated, all right? Or a burning car might land on you. It's possible. That's all you need if you're a conspiracy theorist. It's possible, and therefore it's true. Mad as a bicycle. That's what they are. Okay. And the Zen Buddhists got all excited and said, the human mind, something here becomes real only if the human mind sees it. You know how a human mind sees something? Photon, retina, rods, cones, optic nerve, brain. Watch the road! Cheltenham Road. I gotta finish now. Now, it sounded really logical, and a couple of people wrote some really good books on it, apparently. I forget what the books were called. Zen and the Art of Motorcycle Maintenance as applies to quantum physics, or something like that. And, the Dancing Woohoo Masters. That's what it was called. It finally came to me. George, who I'm coming to visit now, he says, take your mind off what you were thinking about. See, that's what I've done. I've done this whole episode, and I didn't remember what that was called, that book then. And George, who I'm visiting here to watch the grand final with, he always says, if you're trying to remember something, take your mind off it and talk about something else, and it'll come to you because you've instructed your subconscious to just plug away in the background and think about that thing, but make sure you take your mind off it. He says, take your mind off it, and it'll come. If you keep trying to think of it, if you keep looking at it, it's like a leprechaun. If you look at it, you're not going to be able to grab it. Look away. Look away. Look away. Look away. Dixieland. Oh, I wish I was in Dixie. Away. Away. Oh, well, I wish I was in a land of cotton, but not forgotten. Right. What the dancing woohoo masters? What was going on there is that some Zen type of people heard about this and said the human mind, physical existence depends on the human mind thinking about it. A little bit like The Secret, if you know about that, And these books sold fabulously well, mainly because the people who read those books didn't understand quantum physics, and therefore they sold well. And they also didn't understand Buddhism, and therefore the books sold doubly well, because they sold in India as well. And the only problem with those books in claiming that quantum mechanics and woohoo-ness, Zen Buddhism and all that sort of stuff, were unified, because the mind and reality were connected in some way. The only problem with those two books, I've arrived at the factory, was that they were bollocks. It's been proven since. Just total bollocks. Have you got a copy of those books? In the bin. No, don't. Now, apparently they're actually really interesting reading, because, read them anyway. They're full of shit, but read them, And I've arrived at my destination, but that was my introduction to quantum physics. Clear as mud. Could you do that back in the old days? I just went from Essendon to Dandenong on 1 cup of hippie tea. Bye-bye.